What's Gucci, everybody? It's Apple Juice Scholars again, and today I want to be talking about data structures. This is the first video of all the data structures I'm making, and today I want to talk about stacks. Stacks is a very easy data structure and very easy to understand, but has a few good uses, and I think you'll be able to see these uses in real life. So without further ado, let's begin. Now, if you don't know, a data structure is a way to store information in some way and use it and has special rules about it to be able to manipulate this data and add it, delete it, or do something to it to make it easier for the person, for the programmer. Now, essentially a stack is something that as you put an element on top of another element, and you keep on doing that. And if you want to get an element from that stack, you can only get an element from the top of that stack, because if you were to get any element below the top, in the middle, or on the bottom, you would break the stack. So you can only see the top of the stack or do anything with the current top element of the stack. So if you don't understand that, I will try to make it even more clear. The stack iconically has four methods. It can push an element onto the stack. This is known as the push element most commonly, also in the Java library. This simply just adds an element to the top of the stack. If there are no elements in the stack, then it simply starts the stack, so that would be the first element. And then again, I can call push again to add another element on top of the previous element I also pushed on. Pop deletes the top element from the stack and returns it. So then I can use that element to do something else, call another method on it, but it also gets rid of the stack, so now I can look at the next highest element. Peek returns the top element, so it doesn't delete or add anything, but it simply looks at the top element, and by looking at it, I can see what I want to do with it and see if it has any special information I want. And then isEmpty is simply a Boolean statement that checks if the stack has anything left in it, because if the stack has a size 0, like an array, then I don't want to be popping or peeking at it, because that would be an error, because there's nothing inside it. Now for a visualization of a stack, a good real-world example of a stack is when you're typing and you make a mistake, you want to Control-Z. The Control-C interface, for example, in Microsoft Word, is about undoing mistakes, like a stack would. See, if I press the and then I type some gibberish and I want to undo that, I simply press Control-Z, and the last thing I added to that stack was typing in SDF-DFD. And so when I press Control-Z, I'm simply popping that off the stack. And when the stack is finally empty, I can't Control-Z anymore. So back to the example, let's just say I make these a list of commands. Let's say I type something first. I type hello. I change font size. Let's do something funny. I change color. And then let's see, I make an animation. If I did all of these things in order, and then I press Control-Z, I would be popping that action off, and it would be off the stack, and my computer would look at the rest of the stack and say, okay, these things are still there, so still keep them on the Word document, or Microsoft Note, as example I was using. And then if I wanted to get rid of that previous color change I made, I'd press Control-C, which essentially is popping that off the stack. And then if I wanted, and then it gets deleted or it's gone, essentially. I didn't mean to put that in a stack. And I could do the same for the font size and the change color. Also, if I wanted to use the peek method, then I could look at what was the topmost element. So right now it's changed font size, so I would peek at it and see, okay, well, the top of my stack is an element that's talking about changing the font size. I cannot peek at the type hello block because that is not at the top of the stack. It is at the bottom, actually, but I can only peek at the top of the stack. And then so let's say I pop change font size, and then I pop type hello, and then I try to pop something else. That would be an error. So if I was going to pop something, I would need to check the isEmpty method, which would return a Boolean of true, and I would only be able to pop something if the isEmpty method returned false. Let's say I pushed something and then pushed another change color, and then I pushed something again on the stack. I like to think of the stack as literally a stack of like paper or blocks because it's easier for me to visualize. And then I pop something, and then I pop something, and then let's say I push change font size back on. It all works beautifully, and these methods ensure that the data structure can only do what it needs to do because that's the rules of a stack. One side note I want to point out is that on the Java Oracle site, which documents the class stack, which you can import from the Java mainframe, as I say, it again has the classic methods empty, peeks, pop, push, and also has search, but I don't consider that to be a basic method of the stack. But also, if you do import the stack from the Java library, you will notice that it has a lot more methods than just these 5 methods. And that is because it extends the vector class. So it has all these other methods you can do that are fundamentally break the stack class, and you should not use these methods. If you have to use different methods in these ones, you should not be using a stack. You should be using something else. Maybe you need to use a vector. But since you inherit from vector, you have all these vector methods like, I don't know, let's look at some. Add all, capacity, clear, clone. You have all contains. You have all these methods that you shouldn't be able to call in a stack. So be aware of that, because programming is a language of least principle where you only want to use what is necessary, so nobody can come along and use change the code and make it delete everything or something like that. Just remember that. Well, thank you guys. I hope you understood what a stack is, and hopefully I can show you some more data structures later. I hope you have a great day.